So we've talked a little bit about water movement in soil, a little bit about air movement in soil, but now let's get more into the discussion of how other liquids move in soil, and let's particularly look at non-aqueous phase liquids. And so we're going to call those NAPLs. Okay, and here is a bottle of NAPL I happen to have with me, and you'll notice that it has a very different viscosity than water does, has a different density than water does. There's a lot of things about that fluid which are going to be new features compared to how water moved in soil. Now, one of the things with NAPLs is they're generally complex mixtures. So why do we care that our NAPLs are complex mixtures of different compounds? That's because each of these elements is going to have its own volatility. Okay. So, and it'll have its own other properties as well, for instance, the viscosity. So if we have a gasoline, which is made up of a vast number of compounds, what we're going to have is a volume of this liquid, let's say NAPL, and then let's divide it into different subvolumes. Okay, so we may have benzene, we may have octane, etc. Okay? And what's going to happen then as this NAPL ages? What happens is different compounds are more volatile than others. And so this compound, this mixture of compounds is going to age. Okay, so now we have this oil in a soil, let's say. It's been a contaminant spill. And in time, the most volatile fractions come off, leaving the less volatile, generally higher viscosity, generally less biodegradable fractions. So when we start talking about non-aqueous phase liquids, we have to think about them in terms of not only what are the properties of the original compound, but also what is the influence of aging on this situation. As you can imagine, the aging is a function of the rainfall, the temperature, the depth of the spill, the biological activity at that site. So this aging is very complex. And from that point of view, we want to emphasize that we cannot accurately predict many of the true properties of NAPLs in the environment. So our accuracy of making predictions of NAPL movement are fundamentally less precise than that of water.